Hi, I'm Shai Silverberg, and joining me here is Devin Crawford, and we're together going to describe two funding opportunities that together are intended to develop an educational resource on the principles of rigorous research. I'm going to provide a brief background to these initiatives, and then Devin will describe them in more detail and show how, in concert, they will address our hopeful needs. In 2011, Bayer Healthcare published a paper in which they reported that 2/3 of their projects could not reproduce results that were generated and published by the scientific community. This and similar papers led to a flurry of articles, just two of which I mentioned here. One in The Economist, How Science Goes Wrong, and another one is How Scientists Fool Themselves. And in many of these papers that try to figure out what is going on with science, one of the items that floated to the top is that training needs to be improved, as clearly stated by this commentary published by the director of NIH, Francis Collins, and his principal deputy director, Larry Tabak. The issue of training was eloquently described by John Ioannidis and his colleagues, who said that little evidence exists about the research training of laboratory scientists. The way that many laboratory science studies are reported suggests that scientists are unaware that their methodological approach is without rigor. So what are the principles of rigorous research? Well, there are many such principles. I'm going to list just a few of them here, and that's randomization, blinding, preventing p-hacking and harking, calculating sample sizes, and transparently reporting methodology and results. Now, because there is a lack of transparency in reporting in many cases, it's not possible to know if scientists have or have not adhered to the principles of rigorous research. But fortunately, in recent years, a number of journals require such reporting, and that provides a glimpse into what was actually done and if scientists actually understand what these principles are. And we're going to show you just 3 examples here from Nature Neuroscience. So the first is the sample size per group was estimated according to standard publications. At least 3 animals per condition or genotype were analyzed. Clearly, these investigators don't understand that sample size will be unique to each experiment because it depends on things like the expected variability, the expected effect size, and so on, and that in the vast majority of cases, 3 animals per group would be insufficient to provide convincing and accurate estimates. The second example, all rats were acquired at the same age and weight and single housed, so there were no variables upon which to randomize for electrophysiological experiments. These investigators appear to ignore the possibility that there are other confounding variables that could impact the results, and randomization serves to equalize as much as possible the differences in confounding variables between comparison groups. The third example, blinding, was not relevant since equal experimental parameters were consistently applied for each sample during data acquisition and data analysis, so the subjective measures were used, and no subjective measures were used. So these investigators seem not to be aware that all people, and that includes scientists, are subject to unconscious biases that can impact the outcomes of the experiment. They can affect how the experiment is conducted, analyzed, or interpreted. Now, these are just examples. This doesn't mean necessarily that training is not good. To get a sense of this, we conducted a survey of all the institutions that have a training grant funded by NINDS in 2018. And we found that only 5 of them provided a course related to the principles of rigorous research. So this clearly suggests that training is insufficient. Now, this might be a little surprising because if you ask Professor Google about elements related to principles of rigorous research, there's no shortage of results. For example, sample size calculation, well over 2 million. And even the least number here, handling outliers in data, has over 5,000 hits. But this actually could be part of the problem. If one's trying to put together a course on the principles of rigorous research, how do you know which one of these hits is worthwhile, is correct, and will actually be able to be harmonized into a cohesive course? So this led us to suggest the following. The activation energy from building a program from scratch is very large because the investigators need to have the know-how, the time, the funds to be able to build a course. However, if there was a free educational resource that was harmonized, comprehensive, modular, adaptable, and upgradable, which would serve as a one-stop shop to put together a course depending on the needs of each institution or each individual teacher, then that would greatly reduce the activation energy. And that is the logic for the initiatives that we have put out. So with that, I will pass the baton on to Devin Crawford, who will take you through these funding opportunities and show you how in concert they will lead to the objectives we're trying to achieve. Thank you.
Thank you very much, Shai. So I will be discussing this initiative that we have recently launched. We have released a pair of funding opportunities, which you can see described here. The first one is creating an educational nexus for training in experimental rigor, or CENTER for short. And this utilizes a UC2 mechanism, which, if you're not familiar, is for high impact research and research infrastructure cooperative agreement programs. So this is a cooperative agreement, which means there will be substantial involvement from NIH staff. And the purpose of CENTER is to lead collaborations across the initiative, as well as to build, evaluate, and disseminate a user-friendly, harmonized, and openly accessible online educational resource. And we're hoping to attract teams with expertise in digital platform development, multimedia production, education, evaluation, technology dissemination, and community outreach to apply for CENTER. The other funding opportunity is materials to enhance training in experimental rigor, or METER. And this uses a UE5 mechanism, which is Education Project Cooperative Agreement. So this is also a cooperative agreement with substantial involvement from NIH staff. And the UE5 mechanism is similar to the R25 education projects, if you are familiar with those mechanisms. So METER will compile and refine the core scholarly content of educational units that are within the online resource. So we're hoping to attract applicants who are individuals or teams with expertise in the foundations or the application of various principles of rigorous biomedical research. And we also say preferably neuroscience because the scientific examples that will be initially included in the resource should be related and relevant to the NINDS mission space. Now, the educational resource that CENTER and METER will be building together will be online, freely available, accessible to those with disabilities, easily discoverable, attractive, harmonized across the resource, user-friendly, engaging, modular, adaptable to different settings, and upgradable. And by the end of the project period, we expect there to be 30 to 50 educational units that are integrated into the resource. And we are defining an educational unit as an assortment of educational materials, lessons, and activities that collectively address a single principle of rigorous research. Now, every single educational unit will contain measurable, attainable learning objectives. It will have an overview that contains both breadth and depth about the principle of rigorous research. We want there to be an inclusion of why the principle needs to be implemented, as well as how to implement that principle. We want real-world neuroscience-centric examples of applying the principle, various interactive components, multimodal media, as well as instructional supports for learners to master the material. And of course, additional resources for those who want more information that is beyond what is offered in the educational unit. So this educational resource also needs, as we said, to be adaptable to different contexts. For example, it should be customizable for classroom teaching. We expect educators to be able to tailor their curricula, use the components of the resource that they find useful in the classroom, as well as to swap out scientific examples that are most relevant to their students. The resource should also be able to accommodate modular self-paced learning. So individuals should be able to direct their own interaction with the content and also be able to access content that is differentiated to their baseline level of understanding of the material. And also the resource should be available for individual guidance in laboratory. So this could be individual mentor-mentee teams, or it could be just an individual scientist in the laboratory looking for a useful resource or practical suggestions related to a particular principle. Integrated throughout the resource, we would like to see key educational principles, such as clear learning objectives that describe what one should be able to do after interacting with the content, and not just what they should know. Resource should be able to accommodate individuals from different backgrounds and perspectives. We want there to be inquiry-based learning, so a more active learning because it's more effective than passive learning, as well as the cultivation of growth and self-efficacy in the learner. Of course, there needs to be relevance, because if it's not relevant, the resource will never be used. And part of that includes recognition of scientific complexity, because science is messy. And so examples need to reflect that complexity. And finally, assessment of behavioral change, because if what learners interact with does not eventually change what they do in the laboratory, then the educational resource has not been effective. Now I'm going to walk through each of the funding opportunities separately to discuss them in more detail. So first, let's look at Center. So the project period for Center will be 5 years, and there is no pre-specified maximum budget for Center, but it does need to reflect the actual needs of the proposed project. The receipt date is October 21st, 2021. And if you apply for Center, you cannot also apply for meter. Importantly, foreign institutions are not allowed, but foreign components to grants given to domestic institutions are allowed. And resubmissions will not be allowed, of course, because there is only one single receipt date. And just for your information, the research strategy page limit is non-standard. We have increased it to 25 pages. In terms of the goals and responsibility of Center, Center will need to provide leadership to the overall initiative. Of course, manage project timelines of developing the educational resource. They will need to coordinate educational and technical expertise related to building that resource. And of course, collaborate with meter awardees to produce, evaluate, and disseminate the educational units within the resource. And part of their leadership, they need to engage the scientific community, as well as organize annual meetings and schedule steering committee and external advisory committee meetings, which I'll discuss a little more later. In terms of the educational resource itself, Center will be responsible for developing the educational platform and ensuring conformity with the technical requirements. They will produce the multimodal educational components, including videos and interactive features. They need to ensure effective educational approaches are included in the resource. They will integrate and harmonize the educational units across the entire platform and evaluate the functionality, usage, and effectiveness of the resource. Of course, they will continually improve and update the resource, and they will be partnering with the scientific community as well as meter applicants, awardees to disseminate and promote adoption of that educational resource. Now let's look at meter in a little bit more detail. So meter awards will be 3 years. They have $250,000 direct cost maximum budget, and there are 3 receipt dates for meter. The first one is October 21st, 2021, which is the same receipt date as Center, but there are 2 additional receipt dates in October 2022 and October 2023. Once again, if you apply for meter, you cannot also apply for Center. However, foreign institutions and components both are allowed for meter. And resubmissions are allowed due to the multiple receipt dates, and research strategy page limit, again, is non-standard. It's at 12 pages. In terms of the goals and responsibilities of meter awardees will, of course, need to manage their project timelines in terms of developing their educational content. They will need to coordinate scientific expertise related to the principles of rigorous research. They will need to collaborate with Center in order to produce, evaluate, and disseminate the high-quality educational units. They will need to attend the annual meetings, as well as participate in steering committee meetings. In terms of the educational resource itself, meter applicants will be compiling and finding scholarly material for 1 or more principles of rigorous research. We expect each meter application to suggest 2 to 5 principles of rigorous research, but this is not a strict limit. So applicants will need to suggest learning objectives for those educational units, as well as scientific examples, and engaging ways to deliver the content within the educational unit. They will need to incorporate the highest educational principles, and they can do that in consultation with Center. They will need to make sure the materials can be adapted for diverse learners and environments, and they will be ensuring the accuracy and efficacy of the learning materials that Center produces and recommending modifications as necessary. And of course, assisting Center and participating in resource evaluation and dissemination activities. So this is a representation of the structure of the initiative. There will be one Center award, and it will provide cross-cutting services like project management, hosting the annual meeting, and actually developing and evaluating the resource itself. Whereas there will be multiple meter awards, and each meter award will be responsible for some number of principles of rigorous research that will be developed into educational units. In terms of governance, the collaboration between Center and meter is vital to the success of the initiative, and one way that that will be facilitated is through a steering committee. So Center representatives, meter representatives, and NIH staff will all have membership on the steering committee, and the responsibilities of the steering committee will be to foster collaboration and regular communication across the initiative, advise on initiative governance, guide decisions on the development, evaluation, and dissemination of the resource, as well as provide input into annual meeting planning. However, there will also be an external advisory committee made up of external experts, and they will provide feedback to the steering committee on initiative governance, accomplishments, and areas for improvement. However, it's important that applicants do not name potential members of this external advisory committee in their applications, because membership on the committee will be negotiated with NIH after funding decisions are made. In terms of the timeline of the award, Center is expected to be a 5-year award, and due to the multiple receipt dates, there will be 3 separate cohorts of meter awards. You can see due to the staggering that this helps even out the amount of work in developing the educational units, and it also helps us maybe change direction a little bit as the initiative develops. And this leads to the following timeline of developing the overall resource itself. So in the first year, we expect Center to build the platform itself and meter awardees to compile and edit their educational materials. So that way in year 2, we have at least started digital production of the components, as well as compiling of the educational units. So that way by year 3, which is the last year of the first meter cohort, we can evaluate and release the first 10 to 15 educational units. Of course, there will always be ongoing updates from user feedback. So by the end of year 4, which is the end of the second meter cohort, we'd like to see 20 to 30 educational units evaluated and released. And then finally, by the end of the 5-year period, have 30 to 50 educational units evaluated and released. I have listed here some additional application details, and these come straight from the funding opportunity announcements. It is very important to read these because everything you need to know about applying and including things in your application will be found in the funding opportunity announcement. So some notes about the budget. Center applicants will need to include an estimate of total development and production costs needed in each budget year. They will also need to include travel costs to annual meetings every year, as well as logistical costs for hosting the annual meeting starting in the second budget year. This starts in the second budget year because NIH will be hosting a kickoff meeting in the first year. Meter applicants, however, will need to include an estimate of cost that is commensurate with the number and complexity of educational units being proposed. So applicants should keep this in mind when they're deciding how many principles of rigorous research to cover. They will also need to include travel costs to attend the annual meeting. There are a number of required components of the application that everyone should be aware of. For both funding opportunities, you will need an institutional commitment letter of support, as well as milestones in the research strategy, because these are cooperative agreements. Milestones are quantitative criteria for success, and so those will be included both in the research strategy as well as in a one-page attachment in other attachments where you will describe a timeline of the major milestones. There's another one-page attachment that's also required, describing how senior or key personnel meet the expertise requirements, and of course, the resource sharing plan. Center applicants, in addition, need to include a collaboration plan a resource evaluation plan, and a resource dissemination plan. And again, the details of what needs to be included are in the funding opportunity announcement itself. I have listed here some important dates for Center and the first round of meter. Letters of intent are due September 21st, 2021. Although letters of intent are not required, this really helps us plan review if we know how many applications we're going to be receiving. And the application itself opens on that same day. The application due date is October 21st, 2021, and this is really important because we will not accept late applications. The scientific merit review will occur in March of 2022, the advisory council review in May of 2022, and therefore our estimated earliest start date will be in July of 2022. And with that, I would like to direct your attention to this website related to the initiative. It contains frequently asked questions and other resources you might find helpful, including registration for an informational webinar that is occurring on August 17, 2021 at 1 p.m. Eastern Time. After that webinar occurs, we will also post a recording to the same website. And if you have any additional questions, please contact us at our email addresses listed here, and I thank you for your attention.